Thank you very much. Thank you. Thank you. Hello, everyone, and very warm welcome to my presentation today. I'm 𝗟𝗏𝗴𝗂𝗏𝗂, and I'm thrilled to be here today from Birmingham City University, UK. So today we're going to go to embark on an exciting journey into the word from language, and this is the title from lived experience, architecting intelligent systems with multimodality large language models and agentic AI. In this session, actually, I'm going to explore how AI is evolving beyond traditional boundaries, learning to see, hear, and understand the word in much richer, more human-like way. We'll delve into some of the cutting-edge research and practical application that my team and I have been working on. So showing you how these advanced AI models are already making a tangible impact. So briefly now, to guide you through this fascinating topic, which it is. So this is a quick look at what we will cover today. So we'll start by grounding ourselves in the fundamentals of human intelligence, then quickly transition into what multimodality AI is all about. Essentially, how AI combines different types of data. Then we'll explore why multimodality is so crucial to understand the core of concept of large language models. And then we'll see how multimodality actually work. The heart of our discussion, I will be exploring research project use cases, and we will see the AI in actions. So thank you very much. And this is the first slide from today, just to ground the topic for you guys. And I'm very interested about this topic. So as you can see, if there is a question to ask, how do humans understand the word? So this is a very big question now. So we can say the human being, understand the word, via five senses. So we can hear, touch, smell, and also taste. So each one of these tastes or scene actually give a different piece of information and different modality of data. So imagine you see a delicious croissant, as you can see, and just by looking at it, so you got some information, but if you smell it, if you warm it, if you will get different, more insights and deepens significantly more information about how it looks like. So this is what you mean by the fundamental human principle in exactly what multimodality AI aims to replicate. So as you can see from here, this is the very, so what does this look like actually for AI? And so multimodality is all about teaching machines to process and integrate information from multiple modality simultaneously, such like humans do. So, and instead of just texts or just images or just audio, AI can now handle all of them and even more complex data types like tables or videos. So if you just think about why bother with all this complexity, yes, the benefit of this actually truly transformative. So firstly, more accurate decisions, yeah, we can get from multimodality. We can look at the better robustness. Yeah, what do you mean by that? So an audio recording is noisy, so AI can still, rely on other modalities, for example. So this is what you mean by robustness. And thirdly, we can say from the slide, this is to improve reasoning more and show the capability of reasoning. And finally, it enables the advanced applications. So, for example, self-driving cars, and if we need to process visual data like radars, and so on and so forth. Specifically, it's my domain related to medical diagnosing system that combine imaging, patient records, and doctors' notes as well. So just in this slide, I will show you, before we even deeper into multimodality, let's quickly clarify what large language models is. So at its core, as you can see, LLMs is a powerful AI model, yeah, has been pre-trained on a vast amount of text. We all know about it. Think entire libraries like the internet and more. But the primary function is to understand and generate and process human-like texts. So they are the engine behind many generative AI that we live with, like ChatGPT, Gemini, and Claude, and Metas, and so on and so forth. So, for example, let's put into together, see how multimodality large language models actually work. So it's a bit of giving an LLMI and ears, that. So imagine you ask an LLM, why is the sky is blue? This is a very good question, from the slide, as you can see. Simultaneously, to show it an image of a blue sky, the multimodality takes your text inputs and tokenize it, breaks it down into smaller pieces, and converts into numeric, which is embedding. So this is the embedding, how it works, and capture the meaning of embedding. So this is handled by text encoder, and at the same time, the images itself of the sky is processed by a vision encoder. So text encoder and vision encoder work together and breaks the images into batches and extract the feature from the images and convert them into another set of numerical embeddings. So this is overall, but now I will be focusing on 3 case studies from the projects we are working and supervising PhD students and industrial research project as well. So with the foundation of the MML, LLMs, let's go and show you now and present 3 different case studies. So the first project is about advanced development of customer assistant chatbot using multimodality to enhance user experience. And this project been up and running now, and it's a fast-paced word, efficient to customer support, and it's running by a multi-award winning company in cybersecurity across the country. So this is the first, and I'm going to show you the problem statement, which we begin with. So, so to be honest, who here hasn't spent countless, this is a very good question, searching for instruction and trying to troubleshoot a problem online now. And this is a very big problem and tedious work and time consuming. So it's been incredibly tedious and time consuming, especially when the information isn't easily accessible, and to extract some information from manuals and, QA's documents. So you are dealing with the specific user manuals, and also this project address this problem. And in the following solutions, we're gonna show you the proposed solution and how we solve this problem actually. So we trying to build a chatbot to simplify accessing information. So and this would be clear for you for the proposed solution now. So the proposed solution was very sophisticated chatbot that leveraged the multimodality capabilities and multi-agent approach. And what that means, it means that the chatbot isn't just a text-based, it wants just to understand your question, whether you type it, speak the text of the questions, or even you show it as an image. So by drag and drop, that. So if you're stuck at any stage, you have to speak, clarify. If you can't speak for disability, you can just screenshot or send a video, by the way. So as you can see from this image on the right-hand side, that this is the interesting various multimodality for input and output. And you can see from this snapshot as well. So this is how image needing help with complex software like Autodesk Maya. So you could upload an image or upload your query in audio and even point to an area of the screen in an image. Just go and just show you the architecture, as you can see. So this architecture for this proposed solution for multimodal QA systems, it's robust and flexible framework designed to handle information sources for user queries. So at its core, the system ingests PDF knowledge base, then user manuals or product documentation, convert all of them by embedding them in searchable, embedding, archiving or directories. When you, as a user, pose a question or just ask questions in text or voice, or raise your query, this text or image will be embedded. So the system now will perform a smart cosine similarity and search and find the best matches with from the knowledge base. If this has happened and matched, answer agent retrieves and the precise responses. However, if your query is outside the predefined and pre-trained, so the React agent kicks in and conducting a web search to find relevant information. So the architecture, as you can see, and just showing you now, just live demo, and so the screenshot now showing you the interactive user interface in the as a prototype, and how it works, and the relevant image, how we upload images, and adding the text and input it. So this is just to show you a very good demo and demonstration, a very short for the multimodality capability of this framework. The second one is this is a very interesting project because we here are interested about smart building. And so let's move to this second case study. So about the showing you different types of problem statement and case study and on sustainability and efficiency within our living and working spaces now. So the project's title and the project we conducted is about data and knowledge driven approach for energy providing in smart context-aware buildings. So our cities now, smart as our cities become smarter, and we are aiming to optimize energy consumption. And this isn't just a cost saving, it's also about environmental responsibility to enhance the comfort of occupants. So for as you can see from here, this is the why this question we can raise in this slide. Why exactly our smart building? What exactly are smart building? So they are technology enhanced structure, and they leverage vast amount of sensors, data analytics, and automation to create more efficient, safe, comfortable environment. Think about living, breathing entities that learn and adapt. So buildings today produce huge amount of data from temperature sensors, occupancy detectors, light levels, and energy meters. So they are inherently complex systems, and managing them efficiently require intelligent monitoring and control. So the goal for that, how to harness and leverage the AI technology to make those buildings actually even smarter and more responsive to the need of the occupants and the environment. So as you can see, this is the evolution. Yeah, this is the evolution now. So the evolution of AI, building product, then of AI itself, and we've moved from simple reactive systems like thermostat and turning on why the temperatures hits a certain threshold to much more sophisticated environment. Next, the adaptive AI, how to learn patterns, and then predictive AI, which anticipates outcomes. So for example, if you need to predict in the energy demand based on weather forecasting to optimize heating, cooling before it's even needed. So let's go for showing you the some profiling of use cases. So as you can see, our specific aim for the energy profile is to make energy consumption data more understandable and generate personalized recommendation per users or by occupants. So we want to enhance the interoperability and also the for each energy patterns. So the objective, to be honest, was threefold actually. How to identify new customer persona based on the contextualized cluster insights, and how to find the most impactful feature to explain energy insight, and the final things was how to turn this complex insight into clear, human readable reports and recommendations. So from here, from this slide, it's showing you, and it represents the energy profile we've generated, showing how different user behavior and external factors influence energy consumptions. So for example, just giving an example now for provide zero at the top here. So multi-generational household shows a consistent evening peak, that indicating someone is almost at home, and so on and so forth for the rest of profile. So profile 1, profile 2, and profile 3 for traditional families, profile 5 which showing you the second home and to illustrate standby base with a sharp peak only during the intermittent occupancy. So the impact of this actually for this, first, it leads to optimize energy usage and by reducing the consumption, but doing so intelligently. The third question, the third one, because I'm running out of the time, so I would focus on the, research projects, which is very important about the multimodality speech, text, and multilingual translation. And this is where we developed actually, and it's called 𝗏𝗏, and then been, updated to Nouh. According to my name, is Nouh architecture now. So, which is very nice and the recognition for the work we've been involved in with the company and for business. And so it's about the multilingual translations and, generative AI for speech and, translation, LLMs to answer technical questions for IT support and also cybersecurity. So this is this is the architecture now in this slide. So in this slide, actually, for 𝗏𝗏, as you can see, truly multimodality and multilinguality, and the core of this idea, and to provide actually comprehensive customer support across over 100 languages. We already begun with English and Slavic and Arabic as well, and now we are working in Thai language and also with Albanian language, so are increasing too much now. So with the aim for that, by leveraging the power of large language models, and from OpenAI, Mistral, Meta AI, and Hugging Face, we can achieve substantial operational cost savings, which it happened, to be honest, and it's significant, reducing the operational costs for those companies. So by automating and streamlining the support processes. I'm going to show you the architecture, and which is Nouh architecture. So behind this, it's sophisticated agentic AI architecture with a departure from traditional rule-based to or non-agentic AI workflows. Yeah, the traditional framework. So this is the we can see, and so it's quite different from the simpler system that follow predefined sequences. So agentic AI is designed to be more autonomous and capable of complex reasoning. So as you can see, and instead of just define step one leading to define step n, and an agentic AI workflow, involves planning phase where the AI makes a plan. So it then execute actions with tools. Then these tools actually can be anything from searching a vector database to performing a web search, then even interacting with a platform like Slack or Gmail. So after this, it reflects on the results of actions, then and either iterates if the result isn't satisfactory or provide a final solution. So what we mean by that is multi-agent RAG, system showing you how different specialized agents work together, allowing for more dynamic, intelligent, and human-like problem solving. More deeper in this, so this is diagram actually, this is the one before I ended up. So this diagram provides comprehensive view of Nouh, which is the neural operated assistant architecture, highlighting how all these components together come together in practical application now. So as you can see in the left, you can see the chat UI, which is the user interface, where user can provide input via speech, text, or images. As I mentioned earlier, in my first presentation, this input flow through, LLM application layer, where speech is converted to text, and our multimodality, our multimodal proposed solution now process the query or processes the query. So the Nouh agentic AI layer, overseen by a supervisor agent in the middle, then orchestrate various specialized agents. So we have dedicated agent AI for IT support, and another one for cybersecurity, and another one for RAG, retrieval recommended generations, and another one for web search, and the third and the final one for vision. Each agent leverage its own specialized database, like IT support database or cybersecurity database, and all of them been vectorized and embedded in using the corresponding technology. See the output actually as shown in the right-hand side, can be delivered as a speech or text, completing the multimodal, multilingual, and agentic interactions. So finally, this is the screenshot actually for the Nouh, of the proposed Nouh architecture AI assistant in action. So this screenshot screens, demonstrate how user can ask complex technical questions, as you can see, and you can see as well the detailed step-by-step responses generated by the AI and complete the sources and confidence scores for the retrieval information. So below, as you can see, the answers, from the agents executed actions, and that multiple agents, RAG agents, and, web search, cybersecurity collaborate to provide this comprehensive response. So at the end, and this is final slide. Thanks for your patience now. I need to conclude that I would like to leave you with some thoughts on where this field is heading, and the future of AI is increasing. So multi-agent AI and society, the society of agents, where multiple specialized AI collaborate to solve even more complex problems, such like Nouh system as we proposed, and also for the generative, BI business intelligence, as well as for knowledge graph continuing to be crucial, and to try to structure and connecting vast amount of informations, enabling more intelligent reasoning. Finally, I would like to thank you very much for the time and your attention for attending today. I'm so sorry for missing the session earlier in my scheduled slots, but it's been a pleasure, to be honest, to sharing this insight with you guys today, and I hope you found it as engaging as I did. So I'm happy for any questions, and thank you for the kind invitation. Thank you very much. Have a nice day.
Thank you.